Hi, here we are, lesson 4 of the slope characteristics of linear relations, which is chapter 7 of our book. So just to recap what we learned last day, slope is the measure of the steepness of a line. The slope is the ratio of the vertical change, called the rise, over the horizontal change, called the run. So the rise goes up and the run goes to the right. That's the positive versions. A line segment which rises from right to left, goes like that, has a positive slope. And one that falls from left to right is a negative slope. Horizontal line segment has a slope of 0. Vertical has an undefined slope because that involves dividing by 0, which we can't do. And the slopes of all segments on a line are equal. So it doesn't matter where you measure the slope, it's going to be the same no matter where you go. Okay, we're gonna develop the slope formula because there's a formula for it beyond rise over run. Rise over run is great when you can look at it and count it like you can with these ones, but we want a formula for if we have either huge numbers or if we don't have a graph and we can't do a nice neat graph to count it. We're going to list the coordinates of the endpoints of A and B. So A is at 1, 8. And B is at 7, 11. Oops, I didn't do my 11 very well, did I? Let me fix that. 7, 11. Okay. And how can we calculate the rise of segment? Oh, I did miss a thing where we were going to actually just count it out and figure out what the slope is. So our rise from A to B is 1, 2, 3. So this equals 3. And our run is 1, 2, 3, 4, 5, 6. Now remember that you're counting jumps, not lines. Okay. So that reduces to 1/2. So our slope is 1 over 2. And if you notice this, if I go up 1 and over 2, or I go up 1 and over 2, and up 1 and over 2. So it's the same no matter where I measure it. Okay. But you do always want to, if you're going to count it, you always want to go from lattice points. You don't want to like figure out what this one is and then, you just don't want to do that. You always want to go from where it intersects points and you know exactly what it is. Okay, how can the rise of a line segment AB be figured out using the Y and the A values? Or so the two Y values. Well, if we do, I'm actually just going to back up a bit and I'm going to label these because honestly, it makes life so much easier. This is my X A, and this is my my Y A, and this is my X B, and this is my Y B. Okay, so it's easier for me to tell what number is what if I have it written out like that. So if I want to use YB and YA, so that's the 8 and the 11, I'm going to subtract them, and I'm going to, we usually, we write it as subtracting like the one that's farther to the right minus the one that's farther to the left. That just gets us the positive, the rise going in the right direction. This is the change going off to the right. So rise equals YB minus YA. So that is going to be 11 minus 8 equals 3. And the run is the change in the x's. So the run is going to be the x sub b minus the x sub a. So that's 7 minus 1, which is 6. And so that actually got us our numerator and our denominator from our rise and run. So we can write a formula which is slope equals rise over run. So it's YB, I always get that wrong, I'm sorry. YB minus YA over XB minus XA. Okay, now it really doesn't matter which one you do first, as long as they stack correctly this way. The B's are stacked and the A's are stacked. Okay, you just get, if I had done it the other way, I would have gotten -3 over -6, which still simplifies to 1/2. So let's actually use the formula now to calculate this. So slope equals YB minus YA over XB minus XA. Now, I do want to show you something, and that is that those negative signs there, those belong to the formula, okay? It doesn't matter here because these numbers are all positive, but I'll show you later because it matters later. So my YB, if I come up here, is 11. My YA is 8. And my XB is 7, and my XA is 1. So this equals 3 over 6, which equals 1 over 2, and I get the same thing. Okay? Do point segment CD. I'm not going to bother doing EF, but we can do CD. So what I recommend if you're doing this is write the values. It's so easy to get mixed up if you're pulling it right off the graph. So easy, and if you get them in the wrong place, it's completely wrong. So what I suggest you do, recommend you do, is look at this. Point C is at 2, 5. That's the coordinates of C. And point D is at coordinates 6, 2. Okay. And then I'm going to label these. This is my X, and this is my Y. And instead of using sub A and sub B, we usually use 1 and 2, like point 1 and point 2. So I'm going to designate this as my point 1 and this is my point 2. And like I said, it actually doesn't matter. So my formula is slope equals y2 minus y1 over x2 minus x1. And then I'm going to plug in my values. So my x, or my y2 is where my y and my 2 coincide. So that's going to be 2 minus my other y, which is 5. And then x2 is 6, right? The x and the 2 intersect here. So that's 6 minus x1, which is 2. So that's -3 over 4, sorry, -3 over 4. Okay, so that's my slope is -3 over 4. And if I look at it on the graph, well, my rise is 1, 2, 3 from graph, -3 over 1, 2, 3, 4 over 4. So I get the same thing. And then it is a negative slope because it's heading down. So just to double check that. Okay. All right. On the next page, we have the slope formula. So m is the variable that we use to represent slope. That is a constant thing that we do. So m means slope. And then here's the equation written with y1, y2, x1, x2. And that's the normal way we do it. This notation, though, is actually really handy if we're calculating more than one slope in a single question. This tells me which slope I'm looking at, from which point to what point. This is just like the slope if there's just one in the question. Okay. So here we go. This is x, this is y, this is x, this is y. And then these are both G's and these are both H's. So I'm just marking those down in there. It doesn't have to be neat. It's just I just have to be able to read it for the duration of this question. Okay. So my slope from G to H is going to be YH, which is -2, minus YG, which is 8, over XH, which is 7, minus, and this is -3. So this is what I was saying about the negative sign before, is that this negative sign here belongs to the equation, and this negative sign belongs to that 3, and you need them both there. And I can't tell you how strongly I recommend that you write this. Every time you write it, you put it as something minus something. Don't make that switch to it being plus in your head, because 1, you can make a mistake doing that and you're never going to find it. And 2, you want to remember the formula. So if you write the formula the same every time, and your formula is that one minus that one, you're more likely to remember the formula, which just makes life so much easier. And then if you get used to this idea that that negative sign belongs to the formula, it makes a lot of other things later on a lot easier. So, please just take my word for it and do it that way. Okay, -2 minus 8 is -10, and 7 minus -3. And if you want to now change that to plus plus, that's just fine, okay? That's fine because you still wrote it out with the minus negative. So you were reinforcing what the formula is. But if you want to change it to minus negative now, that's just fine. So that equals -1. So my slope from that point to that point is -1. Now, if you have time, it's not a bad idea to make a really quick sketch of this. G is -3/8, so it's like up here somewhere, right? There's my G. And 7 or H is like over 7 and down a little bit, so it's there. My slope positive or negative? Well, my slope is negative. Yeah, so that's good. I got a negative number. That didn't take me any time at all to check. And getting your slope, the sign of your slope wrong is a really, really common mistake. All right. Now, Eleanor, Bonnie, and Carl are calculating the slope of a line segment with these endpoints, and their work is shown below. So you pause and see if you can find the mistakes, okay? I'm going to pause and write it down. Okay, so Eleanor, she got the X and the Y's mixed up because she didn't label these. This is the X, this is the Y, this is the X, this is the Y. I'm going to call this point 1 and call this point 2. So she had them upside down. Bonnie swapped her points. So like the 6 and the 10 are point F, and the 8 and the 15 or 8 and the 15 are from the other point. So you can't have that. You have to have them stacked. Like on this one, we had the 15 and the 8 are stacked like that. Okay, so that's what Bonnie did wrong. And then Carl missed a minus sign, and that is the most common mistake that I see. He missed the minus sign for the 10. It should have been minus -10. Okay, that was what was wrong there. So let's do this correctly. So y2 is 6 minus 8 is y1. And then x2 is minus 10 minus 15. Now, do you notice that when Carl did it, he labeled his x and y's x1 and y1 different than I did. He made a different point 1 and point 2. But that's okay. You're going to get the same answer anyway. This one comes out as -2 over -25, and I just simplify that to 2 over 25. Okay, and if we look up at Carl's, if we fix this mistake and put the negative in there, this should have been 2 over 25, like that, okay, which is the same thing we got. So there you go. All right, so that's all you need for questions 1 to 5. So go ahead and do that. Bye.